Writing the equation of a line. So far in this section you've used linear equations to find out characteristics about its graph, the line that it makes when you graph its points. Now we're going to do the reverse. We're going to give you a slope and a y-intercept for a line on a graph, and you're going to write the equation of that line. Don't worry, this isn't too terribly tough. Once you learn the procedure, you'll be just fine. So I'm going to give you a little background information first. You can choose to take notes or not take notes. It's up to you. So, as I mentioned, we're going to be giving you a slope and a y-intercept, and you have to write the equation. So what if that slope and y-intercept were given to you on a graph? Let's say, for instance, you knew that a line went through 2 and had a slope of, let's say it has a slope of 3. How would you write the equation for this line? So perhaps you're just given the line, you have to identify the y-intercept and the slope. So let's try that first. The y-intercept is at 0, 3. And the slope, remember how you can tell what that is. From point to point, you draw a stair step. Draw a stair step. You can do that between any number of points. You decide if it's positive or negative slope. If I write my name on it, from left to right, my name is slanting upward, so it's a positive slope. So it rises 3 and it runs 1. 3, 1. I can see that in any set of stair steps I draw. So the slope is 3 over 1, or just plain 3. So in our equation, y equals mx plus b, our slope-intercept form, all we have to do is take that slope and that y-intercept, which both happen to be 3 this time. I didn't really mean to do that. Oh, I'm sorry. No, my y-intercept is 2. My mistake, right? 1, 2. Let's fix that. It makes it easier to understand, too. So my y-intercept is 0, 2. My slope is 3. Let's get those in the right spots. So remember, m represents the slope, which we decided from our rise over run is 3. And b represents the y-intercept. And so there you have it. This line is made from graphing points that work in the equation y equals 3x plus 2. So this is how we do it if we were given the line, the graph of the equation. We'd take the information from the graph, the slope and the y-intercept. But what if we're just given numbers and no graph? Let's see if we can do it that way. So let's say you're given the information that an equation has a slope of 3/4 and a y-intercept of 0, 2. Well, this one's pretty easy because all you have to do is get the slope in the right place. It's the coefficient of x, some number multiplied by x, and get the y-intercept in the right place. It's the y value from this coordinate pair. Now, how do I know this is a y-intercept? Because x is 0. If they give you a point that works in the equation, that the line goes through, and the x value is 0, that is the y-intercept. This is the y-int. Now, if they'd said the point 3,5 or 2,7 or negative 1,8, those are not y-intercepts because they don't have a 0 where x is. So this is a very easy problem. They gave us the slope, they gave us the y-intercept. All we do is get them in the right spot in the equation. But let's look at another example where they give us the slope, but this is not the y-intercept. It says write the equation of a line that has a slope of negative 2 and passes through the point 3, negative 7. Now you could graph, put a point at negative 2, and then, put a point at 3, negative 7, and drop 2 and run 1, drop 2, run 1, and so you could figure out the y-intercept. But we have a calculating method that's a lot easier. So here's how we do that. Grab a separate sheet of paper, because we're going to need a little bit more room. So let's write our information down. We're going to, first of all, our goal is to write a y equals mx plus b equation. That's our goal. Let's write that down. All right, what do we know? WD, WK, I say for short. What do we know? Well, we know what they told us about the slope. It's -2. We know m equals -2. That's the slope. What don't we know? We don't know b. We don't know the y-intercept. So we have a method of calculating the y-intercept. Here's how it works. This idea that we have a point that the line goes through, the point is 3, -7. That's what we're told here. That's a very helpful thing to know, because what we can do is we can take the equation, y equals mx plus b, and put everything we know in it. We have m, and we also have an x and a y. So if we take our equation, y equals mx plus b, and we replace the things we know, we're only going to have one thing left that we don't know. That's b. And then we can solve for it and go back and write our general equation. So let's do this. Y is -7 in our point that the line passes through, so we're going to replace that y with -7. M, our slope, is -2, so we're going to put that where m is. And x is +3. Notice how I put that in, so I can show that these two are going to get multiplied. And then b is the only thing we don't know at this point. Now, since I have only one thing I don't know, this is an equation that's solvable. How do we solve it? Well, we start with the busy side here, and we do this calculation. -7 equals -2 times 3 is -6, and that's plus b. I almost have b alone. I only have one thing to get rid of on this side of the equation. How do I get rid of it? By doing the opposite. I do that on both sides. 6 and -7 is -1, and I have my answer for b. But remember, we're not done here. That's not really the answer. Our goal was to write a y equals mx plus b equation. So here's our last step. We go back to using general y and general x, but in the place where we have m and b, we actually put in our values for the slope, -2, and our y-intercept, which we just solved for, -1. Now we have the general form of this equation, which we could graph, we could put input and output values in, and we know that it's linear, that it has a slope of -2, and this is one of the points on the line for that equation. We'll practice another example in just a bit.